Hello again. Before we get into a really detailed study of electrochemistry and galvanic cells and manipulating all of that, we'll look at just a couple of basic things about Ohm's law, current, amount of electrons, moles of electrons, and so on. I'll do a couple. I'll start with this one here. We want to electroplate nickel onto some base metal. Doesn't much matter. We're going to have a nickel 2+ solution, and it's a 2-electron reduction to give us nickel metal. And what we need to know is that 1 amp is 1 coulomb of charge transferred per second. So let's start with that. We know that we've got 0.25 coulombs per second, and we've got 10 hours. So let's just switch to hours because I can easily remember that there are 3,600, 60 times 60 seconds in 1 hour. So our seconds go away. We've got coulombs per hour, and that is going to run for 10 hours. So we end up with 9,000 coulombs. All right. We now need to convert coulombs to moles. So we've got 9,000 coulombs, and we have Faraday's constant to tell us that for every 96,500 coulombs, we have 1 mole of electrons. It's a 2-electron change, so for every 2 moles of electrons, we get 1 mole of nickel. Let's check our units here. We can get rid of our coulombs. We can get rid of our moles of electrons. We now have moles of nickel. So now we need to convert to grams. And so we multiply by the atomic mass. That's 58.96 grams of nickel for every 1 mole of nickel. And so our moles go away, and we end up with grams of nickel as our final units. And that turns out to be 2.7. 2 sig figs. We can keep 1 insignificant digit as a subscript, grams of solid nickel. So that's fairly straightforward. So we quantify how many moles of electrons have flowed, and we can take that to how much product we expect to get, or the other way around. I'll do another one, but I'll make it into a different, another short recording, and we'll go from there. So I will see you later.